Sir, it is visible. It is visible.
Thank you. Thank you.
Good morning to all. First session of this FDP is going to begin. The speaker for this session is Dr. D. Teja Santosh. I'll give the brief introduction of the speaker. Dr. D. Teja Santosh is presently working as Associate Professor in CSC at CVR College of Engineering, Hyderabad. He holds a doctoral degree in the Faculty of Computer Science and Engineering from JNQ-A, Kakinada in 2017. His areas of interest are artificial intelligence, data mining, machine learning, natural language processing. He is the reviewer of international renowned Web of Science journals, namely Willy Expert System, IEEE Axis, Artificial Intelligence Review. He received certificate of appreciation from IIT BHU in August 2022, reviewing 2 book chapters in the published volume March 2020, titled Fuzzy Rough and Intensonic Fuzzy Set Approaches for Data Handling, Theory and Applications. He holds a certificate on Artificial Intelligence Foundation issued by NSS Future Skills in June 2021. He is one of the book editor of 16th edition of Mewai 2023. He has published 4 book chapters with publishers of international repute, namely Chopin, IAENG, Springler, and Taylor and Francis. He is the member of professional bodies of national and international repute, namely ISTE, IEEE, ACM, IAENG. He has 1 granted patent 2022 from ALEF and 2 published patents 2023 from CVR. His credit. He holds 20 Scopus indexed publications, of which 8 are indexed in Web of Sciences. He has a total of 32 publications as on date. He was the resource person for 2 Atal FDP sessions for 2 successive years, 21 and 22, at ALU University Hyderabad campus. And also one of the resource persons in the STTP organized by CBIT. Now I request Teja Santosh sir to start the session.
Thank you, sir. Good introduction for me. So, good morning, all the part. It started as a cool over a period of time. The temperature is raised, but still, we are happy. We all are here now, and it is that has kept on both the departments, both mechanical engineering and computer science and engineering, machine learning, FDP. For any further ado, we will I think I can stop video for bandwidth purpose. If any requirement is there, I will show the start my camera, right? Fine. So session, the topic is introduction to machine learning. Yes,
I request all the participants to mute themselves.
thank you. Right. So we'll continue. So these are the points that I would like to talk today, right? So then machine learning as a branch. So what is the motivation for AI researchers to move towards learning. And the advantages of learning, right? We come to the types of machine learning. The machine learning algorithm in this FDP we categorized under various types, and of course we will try to understand the challenges in machine learning while performing with or various while automating various tasks, right? And then we immediately come to uh, understand what is the role of mechanical engineer and possible, right, on tasks on physical machine through machine learning. And then we understand the most, that is mechanical engineers connection, and how machine learning what you say supports, or let us say it be act as a uh, the tasks of mechanical engineers, these areas of mechanical engineering. And we also see what are the various specific areas of mechanical can bring improvements, right? We will discuss one application or one area where the integration with about that, and then we will talk about various real world that are available for machine learning. See the workflow machine flow. This machine learning workflow is not in, rather you can use this across all the disciplines, because this is a standard everybody will follow to carry, right? And then the important point is it everything is it required to use machine learning, under which or top points not required. So these are the things that we, right. So fine, we move on. So here, if you observe, uh, you see in traditional computer science, in order to perform a particular task, right, we generally, right, because we are given with a set of instructions in nature, right? So these set of instructions in the form of a program, uh, once we reach its objective, so for what is it achieved or not, did we pursue our goal of solving that particular task by we are writing, we will write a, that is fine. If at all, if the task is single and it is unique, right, then writing a single program is okay, fine. Task is performed by many of the people, right, in and of course these tasks when they perform, measurements are totally different. So writing or doing that solving the task by writing programs is a quite, if I take the example of recognizing digits, for example, uh, let us say in our list of participants, as of now we are seeing 185 participants to write the digits from 0, submit those digits from 0 to 9, and if I for all the 186 participant programs that we have finally to recognize all the digits of all the participants written by all the participants, it is 180. Because if you fully this point, there will be certain patterns, there will be certain regularities in the writing styles of all the participants of these digits, right, which help us to identify the dimensions of and also the writing styles and what are the edges that a particular digit will follow. All those are found in terms of regularities or patterns. So these regularities or patterns, let us say, uh, these can be captured. If these can be captured, then no requirement of writing 186 program. It is better to have, or it is single program, let us say, that can capture intricacies of all the 186 styles, writing styles, right? So that is what followed by machine learning. So what it does is ask for data. It asks for, it could be in text, it could be in images, it could be video or audio, right? So it could be numerals and so on. This data, if the machine learning algorithm asks you to put data, and now the algorithm, it tries to identify these regularities human with it's impossible to identify those regularities. Very efficiently, and once those regularities are captured, those are represented in the form of, so these regularities when represented in the form of a model can be used for on the unseen data, because machine learning machine learning is to work on unseen examples, unseen data. What examples or what data the model is encountered with unseen examples, data or examples that are not while training, while training is happening, right? So at that point of time, to information or labels correctly, right? Let us say, for example, in engineering perspective itself, if I provide gear, right, without informing that it only by providing the certain aspects which are distinguishing in nature, then the model, this particular gear is defective, right? So this prediction is very important. uh, what is for the machine learning engineers who are working in the manufacturing gear manufacturing domain, because if they can find that the gear is defective, the rescrap the amount, the cost for accumulating the scrap comes down, right? The scrap also and also the quality of gear manufacturing will be good, because it has been detected early. So majority of the tasks in what engineering are actually given particular scenario. Yeah, you know well rather than me, because uh, there are certain repetitive tasks perform a particular what you say, in order to come up with a particular end product, right? Automated, can be automated through machine learning, so that manufacturing and the cost to say rework will come down, optimization of manufacturing will improve, right? And you can deliver costs at the right time. This machine learning is to for the mechanical engineering tasks, but it is a addition, it is a booster, let us say, for the machine learning or mechanical in order to improve in a more efficient manner. Right now, we see the definition of machine learning. Whatever we have is simply stated as a single statement. What the definition says, it says systems can learn from data, systems can identify patterns, and systems are able to make decisions, right, without or attention, right? So the ideal is humans should not be there for doing all these things, but there will be there will be a supervision on top of the learned model. uh, Humans performance of the learned machine learning models, because we are also moving towards providing decisions. So when decision making is to be, which is a crucial thing, uh, various tasks, then human intervention is required. These tasks can be performed with the help of machine learning, right? Now, so see, it will be very clear to most of you people. So in traditional programming, this the diagram that you see on top, all of us, because we all have already come across this programming style the first year of BTech itself, right? So I mean, you might have written C language codes while you are there. The traditional computer program, it does is it requires or set of instructions coded, right? Program is required, the corresponding data is also required, because without data, whatever unambiguous instruction is of no use, because the final output that you see is a tangible one, is to be a tangible one, right? But not a set of rules that we have, right? So is this demands for what right set of instructions, right? Because should perform the task for you. For that, you should not provide, must provide clear instructions, right? So when it comes to machine learning is different, right? So for the computer, we are providing data, right? And also we are providing from the data. right? What the data is talking about, which is nothing but the output of the data, right? Both the things we are providing computer, right? Here, the we are not writing any set of instructions. We are making the machine instead of right. So how the computer for the programmer is the instances, the data or the instance and its corresponding output information, right? These two pieces will help the algorithm, machine learning algorithm, to find patterns from the data and they generate what is called as representation of those patterns in the form of a model. We can say in many ways, though it is nothing but a model or a hypothesis or an approximation of the real world or a program, right? So in this slide, we are saying it as a program, right? Identifying these patterns, regularities from the data, crucial thing, which is we in the lab sessions, right? So this means moving away from a programming right set of instructions to how to figure out what are the right set is the important thing, right? We are not writing any code, rather we are making machine identify those rules or patterns from the data, right? Which is a very interesting and which is also challenging because data in real world is in nature. What of our convenience, what we generally do is we consider a linear, right, for which it is possible to formalize the algorithm or the latest expression, and with the help of the algorithm, because of that mathematical model. But still, but in real world, the data is non-linear, right? So understanding the non-linearity in the data and non-linear expression, extracting intricate patterns from the data is important, which it is possible to do in machine learning, right? Now, machine learning branch of AI. So there are so many over a period of time, right? And that machine learning branch also, which are nothing but different types of machine learning. And today we are dealing with the specific machine learning paradigm called, which actually works with artificial neural networks. The underlying concept of deep learning, and upon that we, in terms of the number of hidden layers, what is called as a deep learning network, or to approximate any what you say function, any mathematical function, seems to be a very what you say sophisticated. uh, we can approximate any function, the data as well as the specifics of the deep learning model, right? As it, how did this branch emanate from artificial intelligence? So when intelligence is at its high, um, we the researchers or the community AI the important limitation in which says now will help out to answer the questions, right? Artificial generates a rule-based system, right? This set of rules will cater to the need of the given problem at hand. Is the thought process of AI community until they have found an issue which is nothing but adapt, right? So you see from this slide, the is adapting to the new environment by adapting its behavior, right? So which whose behavior? Well, the AI model, the AI is to be is must be adaptive in nature, because given an unseen environment, given an unseen data, unknown environment, the model should be capable enough to analyze the environment and come up with the conclusion uh, expected from artificial intelligence models, right? So there limitation and AI community to new model or new concept called machine learning. See, no, this if this is the case, when they have developed, is why this machine learning is important today also, right? So strictly speaking, majority of the industries, they are actually moving towards machine learning. Of course, they have embraced these machine learning concepts and deep learning, and they are working efficiently, right? If you see this, we need to understand why this machine learning is important. So machine learning, the dependent aspect for machine learning is data, the lifeblood of all the businesses today. Without data is getting generated. Please, and cat and using that data and say needed information from what you said, which is a challenge actually. There is a statement which says data rich and information. This statement itself is saying that today we have huge amount of data. We have huge amount of data. This data is providing us insights. This data will the industry or the researchers for the purpose of improving their applications or their systems, right? Right, for developing. So you know that not only computer science student will know application, real world application. We all know that the recommender systems, right? All of us have accounts in the popular recommender systems, recommendation systems, like Amazon and Flipkart, right? So these systems, they provide a service called recommendation. The similar kind of products also shown to you, so that all those similar products, and you can uh, check out. You can check out with your interesting product, and of course, the not only product explained why this recommendation has obtained is what is called e-commerce systems today. Instead of providing these recommender systems are also equipped with nations. Why so? Why this recommendation has obtained is also right. So most of you people, I think you are this from your Amazon by uploading your experience in terms of video or in terms of reviews and providing the product, right? So once you upload a video or a image and saying that these are the things particular product lacks, or these are purchasing this particular product and giving a less rating, immediately reduce the reputation of that particular product, because uh, review system is continuously monitored by all companies, product companies, right, to immediately address the issues that are raised on the fly, right? So this is one of the many successful applications in which a machine learning algorithms used, right? So like you can the industries, the product manufacturers will use identify the defects immediately and the what you say solution defects, right? And another machine learning model would be moving the recommendation process, uh, because sometimes the whatever the user wants to see across different manufacturers of the same product might not be visible. This is the one of the important reasons could be the problem with the recommendation algorithm itself. So you can upgrade the existing recommendation algorithm to improve recommendations. So all these things we can do when we have the machine learning, right? So data driven decisions are actually important today, right? If an industry or today, if it is not using machine learning, I doubt that they are very much way behind in the competition in this current world, right? So now on, the advantages, one of the most important, facilitating better predictions and diagnosis, right? So of course the first one is we have discussed in the previous slides, because from huge amount of data identifying patterns, so we try to automate that, and learning algorithms are will facilitate better predictions. This is possible with mechanical engineering, we will see in a moment, right? Now, so types, uh, you see, uh, keeping beside the learning aspects, which we will talk about that in the last session, last day of this FDP, let us say. So the various types machine learning are super, as you see, supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So we our concentration is on and unsupervised learning algorithms, right? So as a part of introduction, we will see all for machine learning, right? See uh, how supervised learning algorithm. So in the name itself, supervised learning, there is some supervision learning process. Some supervision. What is here learn? What is meant by learning? Learning is nothing but identifying the patterns, right? Identifying the complex relationships present in the, right, is nothing but a learning here in in this machine learning discussion, right? So who is doing that? The machine learning algorithm is doing that, right? You see, for the machine learning algorithm, for the sake we are providing as input to as input the data and the tables, which is nothing but data and the output so you see, if you see the data, for the sake of better illustration purposes, this slide has been this image has been considered. Everybody understand, right? You see the data contains different geometrical figures, right? And the labels contain the textual information or the string information for those particular geometrical figures, right? So when these two details are submitted as input to the machine learning, now machine learning algorithm will map input to hexagon symbol, geometrical symbol, string hexagon, right? It will map the symbol square, geometrical symbol shape square to the string called square, right? It maps triangle symbol to the string triangle. So this is a mapping, right? There will be a mapping function which one should provide out the particular with the machine learning should provide what could function. Is that easy? That is the most understanding which particular mapping function for the given problem or problem is important. It requires domain knowledge, domain expertise to the particular what you say mathematical function that maps input data with the output labels, right? So once this mapping has been performed, the algorithm which mapping actually occurs, what is actually happening here is identifying these patterns, regularities from the data, right? So how many triangles are there? Three triangles. So for these three triangles, it has given the label called. How many hexagons are there? Three. So it gives for there will be a counting process of, that can happen as a part of certain class of algorithms require, right, in order to of probabilities, right? You not probabilistic machine learning algorithms will as the crucial information because this count is utilized to provide probabilities for that particular table, right? So of course that we are going to we will see in the upcoming session, right? How do we do that, right? So one is once a model is generated, that is through training process or learning process, a model is generated. So once this to provide predictions. Now the most important thing that we need to be clear here is the word prediction is actually meant for one class of problems called regression under supervised learning. We should only speak the term classification for for one of the data or test data when it's submitted to the learned term prediction should be replaced with classification. Here it is classification, right? So it classifies and shows you this particular input geometry is nothing but a square, or this particular geometry is hexagon, right? So the important thing here is how the learned model is actually performing. So in order to evaluate the model, we define what is cost function or loss function, right? So what is meant by what do you mean by this? The cost function or loss function is, in a simple term, the difference between the label predicted and the label that is coming from the data. Label predicted by the model and the label that is coming from the data. So I'd like to pause for a minute, and I would like to ask the if you have any doubts, you can quickly raise your doubts. And I think so far so good with all the participants in terms of understanding. If you don't understand a particular point, please raise your hand and what is the doubt, sir?
If any doubts, you can unmute and you can ask now.
Sir, voice is not at all clear. It's not good.
Sir, voice is a problem, sir. We
So
are
now
get the
is my
voice
voice
clear.
audible now? Is my voice clear? Is my voice clear?
Now it is clear, sir. Earlier, while you are taking the class,
Okay.
the voice is not at all clear. It's breaking so many times.
Okay. So one
Sir,
minute.
Dr. Teja Santosh,
Sir, please.
please look into it. We have to make it very clear. When more number of participants are there, it is our minimum responsibility to make everything clear. And here I got one doubt, and then
Sir,
one appeal to all participants.
Yes, sir.
I thank all the participants for responding so well to our faculty development program. I am Dr. Venkatramana, Head Mechanical Engineering Department. What I tell you is, it is the first program we are conducting in this area. If you have any doubts, anything, please contact with the resource person and get the things clarified. And the main purpose of this particular program is, in time to come, we can have joint publications in this particular area. And now, Dr. Teja Santosh, I got a doubt.
Yes, sir.
How much percentage of data sets we have to allocate for test data?
Strict rule, or there is no rule as per se, because it is be learned.
Yeah.
Sir, again, it's breaking well.
No, I will look into it, sir. All the participants, I will look into it. I will ensure that he will be stationed in a proper place where internet is adequate and perfect. Now already it is available, but some interruptions may be there.
Now, sir, now.
Now okay, but in between it is being cut down. Naku, what I suggest is,
We will change the location, sir, after for the afternoon session. Now I will. So now here, sir, there is no such hard. Only this much amount of data should go for testing. It when you want to have your model to perform with 90% accuracy, you provide 90% of your data to go for training purposes, right? That means more number of patterns be learned by the algorithm. Due to that, what happens is most in the data can be captured by the algorithm. So when you provide 10% of the test data to the algorithm, to the model, to the learned model, for majority of the unseen data, the model will provide correct classification. Is it clear, sir? Hello, sir.
Sir, your voice is breaking and not at all to understand anybody. That's a problem here.
Sir, 1 minute. Sorting out this issue. Sir, now please tell me, is my voice audible now? Yes.
Yes,
Sir,
sir,
it-
audible. Sir.
But so many times it was interpreted, so many times not clear also.
So, topics, are those topics clear? Initial slides.
It's okay, sir. No issue at all.
So, fine. If you have any doubts, and I will give you my contact details. You can through phone or through email answer your doubts. So, shall I continue here?
Yes, please.
Yes, thank you. So, if you see in this slide, so what we are doing is we are providing data to the machine learning algorithm. So this machine learning algorithm is a supervised learning which asks for label information so that the input data, the output label. So this mapping is nothing but obtaining the regularities from the data. So these regularities that we generally obtain, it could be form of statistical process also, but literally counting how many number of hexagons are there, how many number of triangles are there, and so on. That is useful for other purposes, descriptive statistics. But for now, the machine learning, the supervised learning, once it maps the input instances with the output, it forms the representation of the patterns in the data, and that representation could be in the form of a visible model. It could be in the form of a mathematical. Voice audible now? Yes. So yes, sir. Could you voice audible? So I think I can continue because with all of you. Fine. So trained, once you obtain the model, you provide unseen data, the data that is not present, that is for the when the model is getting trained, and provide as input to the learned model. Now this model, what it does is predicts or it classifies and provides the label information. So it is the responsibility of the algorithm or the machine learning specialist to obtain the accuracy or the performance of the model. Upon test data, right? So for that, person needs to design what is called as cost function or loss function. Now, what is this loss function mean? So this cost is simply the difference between the predicted label and the actual label that is coming data set, right? It is that simple. So this difference raises what is called as an error. So this is to be minimized. This is the goal of a supervised learning, right? So it is to be minimized. Of minimization, it is possible to do. The algorithm will try to minimize, which we say as objective function here. Objective is to minimize that error so that the predictions will be, or the classifications on the test data. Okay, any doubts here? Yes. Any doubts? Fine. We'll move to the next slide. So this is the formal representation of supervised learning. So in supervised is a mapping function is learned from input instances to output labels, right? F is a function from X to Y, right? F is a function from X to what is called as the input. Y holds the corresponding labels. Instances or data both are one and the same, right? And Y holds the corresponding data labels, right? These data labels acts as supervised information, right? During the learning process. So this mapping function algorithmically, what we say is prox is equal to, which is nothing but is function of xi, right? Xi. From where this function comes from? It is from the machine learning engineer or the person who should provide this function. This exact function or appropriate function is given by the machine learning engineer is only any disturbance with respect to internet connection. All right. So this function is the machine learning engineer only with the help of domain expertise. So if that does not have, or if the expert in that particular field and comes up with a appropriate function, right? So now we will see supervised learning, or what is this unsupervised learning. Unsupervised learning works, right? So unsupervised, the data does not have label information, right? So if you see in this, supervised learning works on identifying regular similarities in the data without depending on the label, right? So in the slide itself, it that the data that is submitted for the training process is only data or input data without labels, right? Which is not the case with supervised learning, right? In supervised learning, if you observe in the previous slide, right, in supervised learning, we are for model. But when it comes to unsupervised learning, we don't provide a table information. We only provide data or instances to the training algorithm or unsupervised learning algorithm. Right. So what the interpretation happens before getting submitted to the training process, model training process. First, the similarity, the dissimilarity techniques are applied on the data in order to identify groupings present in the data. Right. So first, corresponding similarity or dissimilarity approaches that are required to form inherent groupings. Is my voice audible? No. Yes.
Sir, it's breaking, sir, so many times.
So,
We are
sir,
unable to
I
understand.
have set up in such a way that my voice is reachable, evident from the what is called as we have the captions here, right? So captions are showing the content speaking. Now, other participant, please yourself and let me know what is the clarity with which you are listening to my voice.
Sir, your voice is breaking, sir. Sometimes it's coming and sometimes it's going.
I will go with another.
Yes, voice is wobbling. I think there could be a device problem as well.
No, sir. There is no such a device problem as I observe because it is regularly updated by me.
Sir, while that HOD is speaking, it was not interrupted. But while you are giving the class, so many times it is interpreting.
While HOD is speaking, right?
Yes, while HOD sir is speaking, there is no disturbance at all. But while you are presenting, so many breaks.
Sir,
Yes, sir.
maybe it is of the place. If you could kindly shift to seminar hall, it would be good, sir. Because here we are having a good internet connection. As you are in the ground floor, maybe because the connection is having little problem.
So we will 1 minute. We will continue, right?
Again lost voice.
Yes. We will break for 2 minutes. Yes. Is my voice audible now?
Yes, sir, but it's echoing.
Of course, it will echo. Yes, sir. Yes.
I will log out. One minute. Leave. Now there is no echo. You can carry.
Yes, sir.
Yeah.
1 minute.
This one. This one. This one.
Yes. Yes, participants, please let me know. Is my
Sir,
voice-
now it is clear, sir. Now it is clear. Echo is also not there, sir.
Okay. So
Thank you.
fine.
పెట్టుకోండి మీకు ఛార్జింగ్ అవుతుంది అక్కడ యూజ్ చేసుకో రెడీగా
Yes, sir. I will now share. Participants, please let me know from which slide you are unable to hear my voice or it is not.
Sir, better to start from the supervised learning, sir.
Supervised learning. Once again,
That's the basic thing, so it is better.
Yes.
But quickly you can cover, sir. Thank you.
Yes. So fine. Thank you. Now we enter into the supervised learning type of machine learning. So in supervised learning, to the supervised learning algorithm, we provide two things as input. And the second is the corresponding labels, right? So when these two things are provided as input to the supervised learning algorithm, the supervised learning algorithm tries to find a mapping function or tries to map the data and the corresponding labels, right? So while doing this, actually what the algorithm is to extract those inherent patterns and associate with that mapping function and provide a representation of that patterns, right? So this representation of the patterns or can be shown in the form of a mathematical approximation, right? So now once a model is learned, we provide test data to the model in order to find the performance, in order to evaluate the performance of that model, right? So when test portion of the data is submitted to the model, what it does is it classifies unseen data with the corresponding label, and it is the responsibility of either the machine learning algorithm itself to evaluate this performance and tell whether the label that is provided by the model is correct or not, right? So to do that, the algorithm or the engineer of a loss function or cost function. A very simple sense to understand, what it does is it generates the error label that is provided by the model and the label that is from the data, right? So when these two labels, when labels mismatch, it says it is a misclassification, and all the test portion of the data are classified, then the cost function, it counts how many number of misclassifications has occurred and provides the error information. Supervised learning algorithm is to reduce this loss, which we frame it as an objective function, right? So the objective here is to and optimize the performance of the algorithm in order to provide correct labels as much on the unseen portion of the data. But the generalization of the model, so the model should be generalizable, which means that in a quite efficient or effective manner. Right. So mathematically, same thing is provided in the next slide. So formally, what we do is we learn a mapping from input instances to output labels, which is shown as f is a function from x to y. Algorithmically, this direct mapping is not possible. So what we generate an approximation for the label, which is nothing but the predicted information by the model. So y approx is equal, h is nothing but hypothesis, not named as model, which is nothing but a function of xi input instances. So who will provide this function? That is here from data, as I told you earlier, real world data is often non-linear. The such capabilities to approximate mathematical function, that expression or mathematical function, the machine learning engineer himself. It is only possible experience, right? So wants to do this, he or she may contact with the domain expert in that problem at hand and come up with the appropriate math, right? So here, as you see, the training data contains, which are nothing but xi and yi, right? Together form what is called as instances, input instances, set of input instances. All these y form what is called as output. Approximation, right? Learn this approximation from the data, right? So fine. So now the second machine learning approach is, the second type of machine learning approach is unsupervised learning. So unsupervised learning, as opposed, try to form groupings in basis of similarities among the instances. By forming similarities among the instances to the training process is a raw data input without labels, right? So in supervised learning, we provide both data and labels, but unsupervised learning, we only provide data and we don't provide any label information. There is no supervision, submitted data, right? So once this data is submitted, from inherent groupings, what we do is we interpret that submitted data and we try to come up with what the data possess, right? And to inform or provide the similarity measures or the dissimilarity measures that are used to form the inherent patterns or inherent groupings from the input data. So once that is interpreted, input data, the algorithm will start forming groups in the data. The groups, the number of groups that the algorithm forms is an important point in unsupervised learning. In the task of clustering, which is under unsupervised learning, the number of groupings or the number of clusters that the algorithm forms is from one algorithm to other algorithm on the same data set. Why? Because the task of grouping itself is if this kind is given to you, right? So as you see, if this kind of data is given to you, some people come up with one hexagons. Some group of people will come the 3 hexagons, in which one group contains 2 hexagons and another group contains only 1 hexagon. In the same lines, there where, right? So why? Because the person, the intuitiveness capture that is person to person in terms of groupings, right? So 3 squares, the person might come up with 3 different groupings or 3 different, right? So you may come up with all for these squares, some other will come up with 3. The notion of grouping itself is a unsupervised learning, right? How do we finalize groupings, right? And how do we come up with the efficient grouping in unsupervised learning is the task that we should do when we understand the various unsupervised learning algorithms, right? Any doubts here? Any doubts? So fine, I move forward. So the formally, if you observe, the model that is learned on the data is a function of input data or, right? So function of input label. So this function, what it does is, right, it learns, or what it does is it tries to capture in the data, right, inherent groupings with the help of various similarity and dissimilarity approaches, right? So might have understood difference between a supervised learning and unsupervised learning approaches. Participants, if you have any doubt, you ask the doubt. Fine. I think I can move on. Right. So supervised learning, the semi-supervised learning, here if you observe, it is the combination of both supervised and unsupervised learning. So if you see data and small amount of label data, both are getting submitted to the algorithm. And what the algorithm is trying to find is, it tries to form a model, right? The semi-supervised learning, right, with the labeled data, and this labeled data is further used predicting the groupings in the unlabeled data. So here data are useful for generating predictions, right? Not unlabeled data is useful, but both the data are useful because the supervision information is obtained as a prediction from the model, and that supervision information is applied on the unlabeled data. That is the beauty of the semi-supervised learning approach, right? Both the things are used here. So in this kind of technique, you have less amount of labeled information. As you see from the image itself, the amount of labeled data is very less. And in that situations, right? So then we move on to the last technique, that is reinforcement learning. So in my understanding, in reinforcement learning, before talking about reinforcement learning, in all these 3 cases, environment, we provide data from the external environment, we submit the data, right? So in reinforcement learning, the environment itself helps you to generate the data. Provides the facility to generate the data, right? and that generated data is taken by the techniques or algorithms to what is called as policy, to form what is called as policy. Policy is a mapping states to output actions, from input states to output actions, and these policies will rewards, right? A policy function can provide a reward also, right? So this, if you see, this is a cycle, right? This is a cycle. Majority of the grid environment problems will generate the data by themselves, but for few problems, input data is approach also to data output that is required. Let us say data that is reinforcement with reinforcement learning and output. It is with the help of policy. For a better example, we take the video game that have actually played in our childhood. What happens is, when you are moving forward, when any villain or any, you will immediately kill that person. Fairly problematic to you, right? You will kill that person. Once you kill that person, what happens is the score will increase, right? Reinforcement learning works on the principle of what you say minimal signal. It works on the principle of minimal signal. So like either reward or punishment, right? So to provide rewards, like when you're moving ahead in the game, you will score will increase, right? That is nothing but reward. So you are encountered with the opposition, and when your energy is coming down in the game, that is what happens, will come down by penalizing that reward, right? By penalizing reward, your reward will come down. So these are nothing but credit assignment, right? This is not is quite useful in path planning for the robot, and from time to time, while it is moving in the forward direction, by providing one at a time, right? What happens, algorithm will increase the rewards, right? So goal, or when the target location is reached by the robot, the reinforcement learning algorithm will generate the total reward, right? And it shows up what policy that the robot has actually followed to move towards the. So any doubts? Any doubts? So quickly we go through the chat window to see if doubts are there. So there is an opportunity to your hands, and you have some doubt, so that I can reach out to you. Ask your doubts.
Participants can unmute themselves and they can ask.
So please explain cost function or loss function. Yes, sir. There is no, Nine Satish sir, there is no difference between a cost function both the cases. What is actually
Sir, again,
yes.
again, voice problem is coming, sir. It's not audible properly.
Now
Now it's okay. But while giving a lecture, it's not.
Sir, I think I have come to a location where signal is full and connection is full and what you say, it is clear from my side.
Sir, maybe the PC is having some issues. You can
Maybe
check. The PC, whatever you are using.
in the afternoon session, I think you might have listened to all these slides till.
So many times it's breaking.
Sir, there is an alternative location that I will go to the for the afternoon session, and from there we will
Better to change the PC also. Sir. Your
sure
computer.
sure as said, we will also look into it and we'll change the PC also. Right now, sir, now there is no cost function and loss function. The thing is both are one and the same. Here what is actually happening is we are trying to show an error that generates an error from the predictions. Predictions are obtained. The obtained prediction are the label that is already available from the compared, right? So if both the labels are correct, if same, then the last function will say that there is no mismatch and it says both are correct, both the input instance, the test instance is correctly classified, right? Is some mismatch. If there is a mismatch, let us say in terms of labels, or the label given by the model and the label obtained from the data set, there is a mismatch, then it says both are not matching, or the function says both are not matching, right? And it treats it as a loss. It treats it as a loss, or it is cost in the sense, in terms of counting, if you count the number of misclick is high, we say the cost is high, cost of error is high, right? Accuracy, the accuracy is less, right? In terms of loss, if you see, loss is once again the misclassification, right? So how many number of misclassifications that is nothing but the loss that the model has incurred on the test portion of the data, right? The performance of the learned model is nothing but in terms of loss function, it is nothing but loss function is if it all it lies in 0 to the loss value is lying in 0 to 1 region, then the loss is nothing but 1 minus accuracy. The loss is nothing but 1 minus accuracy. Any doubts here? Sir, question, sir?
Yeah, participants can unmute and they can ask the questions.
Satish, sir,
Sir, am I audible to you, sir?
yes, sir. Please go ahead.
Sir, I am Dr. Subodh Kumar from SR University.
Yes, sir.
Actually, first I would congratulate you to arranging this kind of very advanced topic for us.
Sure.
Sir, I want to know that in what aspect this machine learning is different from artificial neural network.
How this machine learning is different from artificial neural network?
Almost same, or is there any some differences in between artificial neural network and machine learning?
Sir, if you see the history of both machine learning and artificial neural networks, right?
Hmm.
Artificial neural networks started way back, right? Around 1940s or 1950s. Initial work has started,
Yes,
and
yes.
machine learning has obtained as a discipline of artificial intelligence during 19, right?
Yes, sir.
So here, if you see artificial neural network altogether, it is a type of learning technique or learning approach which takes into consideration input data, and what it does is what you say weighted uh, values. It forms weighted values, and it tries to generate activations on those weighted values, right? So which is not the way of uh, in machine learning, right? So artificial neural networks initially started with a linear separation on the, and gradually it has also taken into consideration the nonlinear data, and by applying concepts of calculus on outputs that the artificial neural network has generated, it has come up with it has gone to that level, it has gone to that stability where it is able to understand the nature of the nonlinear data predictions correctly, right? The way the entire setup is done for languages will actually theoretically mimic the architecture of what you say human neurons, human neural network, right?
Okay, sir.
But practically saying, the in the neural network has work in terms of the faculties, the categories, right? One set
Okay,
of
sir.
neurons will work understanding the information received from the eye, one set of neurons will understand the information received from the ear, and so on. So this is the real way that the neurons will work, right? Did I answer your question, sir? Hello? Yes, sir.
Yes, sir. Thank you, sir. Now, actually, I didn't respond on time, sir, because my voice is unmuted. Thank you for this nice thing, sir. Like one more question, sir. When we are studying this artificial neural network, there is some basic algorithm we used to means we have studied, like backpropagation algorithm. So,
Yes,
in
yes.
a similar manner,
Uh,
for machine learning, is there any fundamental algorithm we have so that we can understand that this machine learning course very easily, sir?
yes, sir. Here now we are actually different types of machine learning tech or approaches, right? So these categories, there will be algorithms that we are going to see in the future coming sessions, where how this algorithm will consider the input data and how it forms patterns, how the input is mapped to the output, all options.
Much for this answer. And I had
Yes,
only supervised learning, unsupervised learning. Now you're talking about this hybrid learning and so
yes,
in
yes.
the maybe in the upcoming those things I will learn from if I.
Yes, sir.
Sir, thank you very
Will
much.
Yes, sir, no problem, sir. We see into it these techniques also. What kind of mechanical engineering scenarios, semi-supervised learning, and reinforcement learning we will see, right? Whenever the sessions pertaining to these will be there in the upcoming. Fine.
Hello. Hello.
Yes. Hello. Yes,
Good
sir.
afternoon. Vinay Kumar Reddy from
Good afternoon, sir.
Sir, can we implement this condition monitoring of any generally condition monitoring will be taking place 6 months or 1 year like that. But by using this machine learning, can we check the machine day by day or
Yes, sir. Yes.
once in a week?
Yes, sir.
Possible?
You can schedule the machine, what to say, how the machine is actually performing, and you can monitor the performance of
Sir,
the
your
machine. Hello, sir.
Your voice is not audible, sir.
Now is it audible? Now is it audible?
Voice is breaking. Since morning, same problem, sir.
So now, sir, please. No, please.
Now it is okay.
Now clear. Now the point is, machine learning. When you use machine learning, right? When you use machine learning, monitor your machine on a, let us say, on weekly basis or monthly basis or fortnight basis, and you can record or how the machine is actually its task, right? And the values that the right, you can what you do is you can basic tests on the data, and you can come to a basic conclusion that the present in the data. So in some cases there is there is possibility of data itself with the help of different plots, manufacturing data. When you do visualize, there will be certain techniques that will help you to understand that these many number of examples are right, and these many number of examples follow the 5-point summary, and these are the attributes that are irrelevant, and you can come up with the right set of attributes for the downstream task of machine.
Okay, sir.
So did I answer your question?
Okay, sir. But the thing is, suppose
Sir,
to give the values priorly to the machine. So if it is not run perfectly, then automatically this software will identify that this machine is not working. That's what you are saying.
yes. Immediately it will predict immediately predict and tell you that this defective or this material is fatigued. Okay, fine, we'll continue here. So you see, now if you observe from this slide, in our FDP are shown under these two categories. So in unsupervised, under supervised learning and under classification, these are the algorithms that we cover for mechanical engineering scenarios. What are the algorithms that are listed here? Naive Bayes classification algorithm, decision tree classification algorithm, logistic regression, k nearest neighbors classification algorithm. We have linear regression, multivariate regression techniques to predict the continuous data. So coming to unsupervised learning, under clustering, under the task of clustering, we will see k-means clustering and algorithms, right, to form inherent groupings in the data from the data. And we also deal with the concept of dimensionality. So if the data after pre-processing or of attributes or features or dimensions. All these three are one. How to deal with these huge number of dimensions and come up with a good set or a only requirements that will reconstruct the original data, which is nothing but dimensionality reduction. To understand under dimensional reduction is principal components analysis, PCA, right? And also, yes, yes, any doubts? We also see in the as a part of FDP, in the last day, on the last day of this FDP, we will talk about artificial neural networks. So fine, we now talk about the aspects of mechanical engineering, and slowly we will move on to integrating machine learning aspects of mechanical engineering, right? So first of all, what is the role of mechanical engineer? You are very much, you know very much rather than me, right? Can anyone please inform me what is the role of mechanical engineering? It is visible from the slide itself. So mechanical engineer builds the physical devices for the people to interact, right? So what are the various physical devices that the mechanical engineer will build? If I consider car, thermostat, right, medical devices, right, and so on. And this list is not right, it is not exhaustive, right? It goes on, right? Now why should I care these things, right? That is the most important question, right? Mechanical engineer builds these physical devices. What is the need to understand about these physical connections, right? So you see, while building these physical engineers often confront with various challenges in the mechanical engineering processes, right? So and most of the mechanical engineering processes are often repetitive in nature, right? The tasks that you perform as a part of mechanical engineering processes are repetitive. So when these are repetitive, right, and which are actually sequential, let us say, which are actually sequential, strictly speaking, if anything happens at the last in the last, any deviation has been identified in the last task, once again you should trace back which is the cause for the problem in the last stage, right? So this calls for this is a very Herculean task. This is a Herculean task, right? And dealing with this kind of problems every time will what I say will what I say ask for, will call for what is called as negative things. Let us say in manufacturing, if this is the case, be manufactured, and if this problem persists continuously, then what, it is not possible to deliver the manufactured cars to the showroom, right? So what promises that that the car manufacturing company has made, it cannot what you say satisfy that promise, right? There should be a particular phenomenon, problematic phenomenon that will that is persisting while handled with the help of machine learning, right? When you integrate machine this particular what is say processing, when this particular manufacturing process, what happens is automating certain things, right? You are trying to implement intelligence. You are trying to bring out intelligence in that repetitive process, right? So when you are automating in this process, you are actually doing what is called as intelligent. And when you do intelligent automation, what happens is the problems that you have identified at the last stage could be at the early stages itself, and you can do what is called scheduled downtime, right? You can of scheduled downtime, convenient scheduled downtime. Can replace We can replace the component or a machine or equipment that is actually used as a part of manufacturing process, right? Without disturbing to the actual timeline for delivery of the products, goods, right? And this is quite useful where mass production actually carried out, right? Like if you see manufacturing does mass production, right? So more number of for different for different industries uh, manufactured in the mass in the form of mass production. So at that point of time, quality is of highest factor. Quality of the gear is of highest factor particular situation. So at of time, if the manufacturing process is highly monitored with the help of machine learning and automated through machine learning early stages, and without ignoring effects, once those are identified, immediately reduce the what you say scrap, and and you can gear, right? And you can optimize the manufacturing process also, right? So, I think I have explained to you the difference in machine learning, presence of machine learning, and without machine learning in mechanical engineering domain, right? So, as the physical connections, so what I mean, so this statement. Mechanical engineers design the products that people interact with, and these products, right, are built carefully. These products are built carefully uh, in the specifications, right, by carefully understanding the design aspects for the sake of manufacturing. I'm once again talking about manufacturing because what to say explainable for me, and it is very what is say convenient for me to make at least what you say understand about the what is say association between machine learning and engineering, right? So are to be done perfectly. The physical connections are to be done without any what you say problem, without any deviations, right? So to do that, machine learning uh, plays a central role to what you say make these connections more true, what you say more clear, right? More clear and more better, right? So because why I am saying this, because sometimes there will be inspection team in the quality control, let us say in the quality problematic what you say surface of a particular which might be at a later at a later point of process, right? So machine learning algorithms will also take into will take the will embrace the concepts of internally use machine learning algorithms only. They deal with the computer vision as it is possible to see where the break or defect lies in the gear with the help of camera and properties of the camera and the what you say the geometrical aspects of the vision, and thereby possible to detect the defective regions or defective regions on the surface and come up with the solution, right? It is possible machine learning. So not all times defective surfaces are visible for the inspection team because the defect the deviation in the surface it might be there which at the below location surface level, right? So clearly it is taken into consideration techniques with the help of computer vision techniques and machine learning algorithms. So any doubt? So as I told you, it is not a replacement. Machine learning is mechanical engineering. It complements mechanical engineering tasks, right? And also improves the way the mechanical engineers provides you and provides end products, right? Better end products, right? So what are the various areas or specific can bring improvements as we have seen in the inaugural session also the dignitaries on the dais have told certain areas like predictive maintenance, right? Energy efficiency, design optimization, right? Material selection, robotics and automation, right? All these things, all these areas, yes, we can apply machine learning algorithms to bring improvements for whatever objective that the task is trying to achieve. For the task is actually performed for the sake to achieve this machine learning algorithm improves, right? So some charts, fine. Consider one particular area like quality control. So what are the various repetitive tasks that are present in quality control? These are the various repetitive tasks as you see. Visual inspection of products as I have, and then dimensional inspection of products like length, width, and other dimensions, geometry. To gear teeth itself is dimensionally it should be correct, right? Small those tolerances, the teeth will not be useful, is not useful actually. So testing of the material for a particular for the manufacturing task, right? Given manufacturing task, if the proper materials might be similar, but all materials as the proper cannot replace one material with other material for the sake of what you say material what you say for the sake of structural engineering or anything, correct material for the sake of task so that it meets the quality, right? And then functional testing, components assembly, now we talk in terms of its automation. We inspect that assembly also, components assembly, how correctly the components have, so that the the final task is performed with the help of this robot shoulder, right? In the industrial plant, how the device to perform a particular task, the joints will support the end effector to reach out to real world and do a particular task, right? And then product packaging inspection also follows certain standards, right? Quality packaging is required, meaningful packaging is to be done. So color matching of materials and statistical process control, these are repetitive tasks which can be actually automated, right? Automation will improve accuracy, speed, and consistency process, right? So speed, the most, yes, now is my voice audible?
Yes, sir, audible, sir.
Speed at which the automation or the is one thing which is actually depending on what is called as accuracy and consistency, right? So process with the consistent consistency, because it should it need the inspection, or it should the inspection team, right? So to come out as a product, right? It is possible through this machine learning. So what are the various challenges faced by machine learning engineers when embrace? These are the various challenges. The first and important thing is interdisciplinary knowledge. It is what we are trying to bridge this gap in during this discussion, right? And also, yes,
Sir, actually, time out, sir. We want to start the next session by 2 o'clock. We can continue the session by 2 o'clock.
session we are ending this session. We talk about one or two things here. So lack of label data and knowledge are the challenges faced by mechanical engineers. These are the things that we see over a period of time that we go through in supervised learning and unsupervised. The real data, right, for where the data is available here, and also CAD based data sets are available. These, you see the huge amount of CAD images, 3 for the sake of deep learning and also for machine learning, and also which this is the machine learning workflow that we follow in the tomorrow's session, right? This session now. So before ending this session, please we do machine learning. When learning, it is these are the 4 reasons or 4 situations where machine learning is used. When human expertise does not exist, when humans like recommendations, when this is the situation, then you can use machine learning. And if you see, machine learning is not always required. If you want to calculate payroll, the Excel will do that. For that, machine learning is not required, right? So in fact, you will be, when I will talk while regression, we will talk the concept of required, right? We will talk about that while so then finally, these are the conferences and journals where you can submit your automation works here, right? So with this, I will end the session, right? These are the from where I can I have the images and slide to prepare these slides, and Thank you. If you have any doubts, you can now raise the hand. Any doubts?
I think no doubt, sir.
Okay. So then we will now break for lunch. It
Yes,
is
sir.
already 1:40. We will once again start at 2 p.m.
Yes, sir. 2 p.m. will start.
So thank you.
Thank you, sir.
Thank you. In terms of loss, if you see, loss once again,